Okay, so at this point, I have no idea what you have up and running, so I'm going to assume you have nothing at this point, and we're just going to start from the ground up. We're going to see if we can go through this quick. Basically, what I'm thinking is that I encountered a question here. This is what you did in class, right? So here, let's look at this. So we're launching this ballistic sponge dart, like a Nerf dart, right? And we're gonna shoot this thing, and we want to model it. And we have these formulas, right? Formulae that we were given in the last little bit, and we want to use those. And then we have some information that's given to us, okay? And so the first thing is I would like to plot this. I have no idea if you have this running or not. Let's go through it. Let's just try this. So here's what I'm thinking. I want to look at the editor and I want to look at my formulas kind of simultaneously and see if we can figure this out. So I have this height equation, and I was given some info, good old info, that tells me when it's fired straight upwards at initial height of this, it takes this long to reach the ground again. Use this to find the initial velocity of it, right? Okay, so let's start there. So that means that that's going to be this. So if it's fired straight up, then we're going to get this, right? We're going to get this equation, right? And oh, this is an angle. This is our 45-degree angle. This one's straight up, right? Height versus time. And we know the final height, because it's going to hit the ground, is going to be 0. So we can actually put a 0 here. So if it hits the ground, right, oh my gosh, that was going to turn chaotic. If it'll hit the ground, this thing equals 0, right? Which implies that I'm going to get 0 equals this thing, okay? And we could solve this pretty quick, right? So you want to solve this for V naught? Fine. Let's here. I'm going to move this to the other side of the equation, right? So move this and move this. So I'm going to have minus H naught equals this V naught T, right? And then divide by T, so that one will lose a T, so I'll get 1/2 GT minus, and now I'm going to have a fraction H naught over T. Okay, equals V naught. Alright, so we got a formula ready to go that we made from vertical motion, okay? And that's going to be from our given info, so that's going to set us up. So we could probably just plug this in for right now. So let's go ahead and do this manually. So our V naught given is equal to this stuff. And that's all given in your problem, right? You have an initial height and a time, okay? And so using that, you'd be able to solve this, okay? So now you're going to use that initial velocity for the next part, okay? An experiment showed that the dart flew this far when fired at 60 degrees. Use the initial velocity found above to plot the distance the sponge dart should fly using basic motion equations. So this is kind of our ideal situation as opposed to the real situation, right? That thing hitting all the air and stuff. Okay, so what was it? There was a 1/2. V naught squared cosine squared of theta it says tangent of theta. Right. So this should do it, right? Oh, this should be a 2, right? Okay. Hold on. Okay, so here's what we're going to do. I got my MATLAB ready to go. And we're going to go try to plot this thing. G is a constant, right? So here, let's go plot motion. Okay, so G will be, what are we in? 9.81. I believe we're in meters. Is that correct? Can I verify this? Yeah. Okay. Cool. We're good. And what else we need? So we're gonna have V naught, right? Which we just calculated, right? So we got that. So I'm going to cheat, but I told you how to get it. Okay. And we're going to continue on this way. Theta is 60 degrees, right? And why not is, I have no idea. Um, 0.395 will keep. For now. Find out I'm wrong. Okay, so here we go. We're gonna go plot this thing. We have the y versus x equation, don't we? Here, let's just keep this up. So this is our y versus x equation. We can program that with no problem. So what do we got here? We're gonna do it like this. I'm gonna do A equals negative G divided by 2 times, let's do it like this, V naught squared times cosine 60. Does it do radians? I feel like we've done this before. Hold on. Cosine of 30. T. Just display cosine of 30. So I'm gonna go check what mode we're in. So this is junk 2. And here, cosine of 90 should be 0 by this theory. It's not, right? But cosine of pi over 2 is 0. What is this? Something really close to 0? What the hell is that? So this should work, right? Cosine of pi is what? -1, yeah, it's in radians. Okay. So, we got this. There's my converter. Okay, and that's all in the denominator, right? So I close that. times x squared. What is x? We don't know yet. Plus x times tangent of theta, which is going to be 60 times pi over 180. Plus, and then why not? Because why not? Okay. And we should be good. Oh, that's the whole equation. I was just going to do A, B, and C. You know what? Let's do it like this. There's A. Dun, dun, dun. Sorry. A. B is the middle term, yes. B. C is going to be this term. C. Okay, now let's do it. That's why I was confused on what x is. So x is going to be 0. X land is going to be x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right. A is negative, so I want the negative answer up here, so that a negative divided by negative is positive. Now x can go from 0 by 1 up to x land, or 0.01. I don't know how much resolution you want. Okay. Did that make sense? This is where we're going to land. That's quadratic formula. I just want one of them. And I'm going to start it from 0. We're going to go till we land, right? Now y is a times x squared plus b times x plus c, right? I'm a pro at this stuff. Okay, so here we go. You ready? We're going to plot. Where are we at in time? 12 minutes. I went way over. All right. Plot. Here you go. We're going to plot x against y in a red line. Dude, we're just gonna write over junk again. Oh, it didn't like me. What did it not like? Ax dot squared. Do we do that in here? We do. Okay. Bam. Look at that. Okay. So what was our question? Sick. We could add labels to this thing. I'm gonna make a separate plot thing. Okay. The distance it's expected to fly. So now we gotta go figure this out. So let's go see if our algorithm works right. So that's this. So we want to just display that. Display the x land. So when we run this, we want to know that, right? It looks like it's 9.5520. Let's go check this. 9.5559. We'll take it. You only have to be within a certain range. We've got some stuff going on here. And then how far off are we? Well, we should be able to subtract these and get it. Copy paste your code here and put your trajectory. Okay? Oh, I know why I'm off. I didn't carry more of these. That's okay. Okay. Good luck.